Okay, this is going to be a short video on calculating productivity. And we're going to use a couple of problems out of Wiley's Operations Management textbook by Russell, 9th edition. We're going to use problem from Chapter 1, Problem 6, and from Chapter 1, Problem 10 for this. The basic formula for productivity is output divided by input. Now this is a little counterintuitive if you're a follower of Elijah Goldratt's The Goal. We tend to steer away from productivity measures, particularly to make decisions with regard to financial investments and plant performance. So if we were to look at which plant we should close down, for example, we want to steer away from using productivity for those types of decisions, solely for those types of decisions. However, we do use productivity to help guide us in the questions that we ask and how we're utilizing resources and the value of those resources that we're utilizing. So in this case, our output is anything that has transformed from the original input. So we use the total of our finished goods and work in process because those have both been transformed from the original input. The input we would think of as raw materials, raw resources that help make that transformation. So in this example, we have 4 different locations, and we're going to use Cincinnati as the example. We have finished goods and work in process. So our total output, and you'll see I use the sum formula. I like to use formulas and cell references anytime I set up a problem like this because, let's say, for example, our production department called and said, oh, we made an error. We actually have 10,500 finished goods. Now we can change all of the calculations without actually having to go back and re-enter in all of the other information. So we use the sum formula and we highlight both of these 2 cells, and our total output was 11,000. Now Cincinnati, as well as the other 3, had several different pieces that were used to transform into our total output of 11,000 units. We had labor, which cost 3,500, material for 3,500, energy for 1,000, and transportation 250, and overhead for 1,200. So the total value of the resources we used was, again, we used the sum function and highlight those, was 9,450. So back to our original output over input. So we took our output divided by our input, and we get 1.164. To put that in sentence form, we would say that for every $1 we spent on production in Cincinnati, 1.164 units of output was created. So let's take a look at problem 1.10. And here we have 4 different weeks, and we want to determine what the productivity is for each week. Now, what are some of the questions that can come out of this solution? Well, we could determine if adding additional workers created more output. We could determine if a particular mix of workers created more or less output. So job fit, if we have one particular person that when in this mix of 4, 5, or 6 employees is creating additional output, or maybe isn't in a good fit. Those are the questions that we can start to ask by looking at these measures. So we had a total of 2,000 units of output. So we already have that measurement. We don't have to add anything else in. And for week 1, we had 4 workers. Each worker worked 40 hours a week. We used 286 pounds of material. Now some additional information. Our labor costs $10. So we multiply our number of workers by the hours per week by the cost of labor, which is $10. And now we have the total cost, or the total value of the labor used to transform the raw material into an output. We do the same thing for material costs. Material costs are $4 a pound. So again, we're going to take our total number, or total pounds of material, multiply that by 4, and we get the total cost of materials used to transform into our output. So our total cost is the sum of these two. Again, we use cell references. So 2,744. So our total productivity is our output divided by our input. And we want that to be a number and not a dollar. So we say for every dollar spent on labor and materials combined, 0.729 units or 0.73 of product were produced. So I hope this helps understand our formula for productivity and some of the uses that productivity can help us solve some day-to-day operations problems with.